Welcome back everyone. In this particular video, we will see how to find a curve which passes through a given integral surface. Okay, and we will look it through an example. Let us say we are given a question which is like find the general integral of PD 2xy minus 1 into p plus z minus 2x square into q equals to 2 into x minus yz. Okay, and also the particular integral which passes through the line x equal to 1 and y equal to 0. So basically, this particular question can be divided into two parts. First is general integral and then a particular integral. So our approach will be to find the general integral of this particular PD by the methods we have been utilizing or using earlier. And once we find that general solution, we will use this given condition to get the particular integral. So basically, we will be getting a solution in the form of C1 and C2, which are arbitrary constants. And we will use these given conditions to get a relation between C1 and C2 and eliminate these two. Okay, let us see how we will do it. Now, this given PD can be written into auxiliary form as dx by this particular term equals dy by this particular term and dz by this particular term. Okay, that is what we have written here. Now, if we take multipliers as z1 and x, what it will be like? We will multiply here by z, here by z, here by x, here by x. No, here it was by 1, here 2 by 1, and here by x, and here 2 by x. Okay, so this is what we will get. Now, if you observe here, see this z into 2xy, it will be 2xyz, and this 2x into this minus yz will get us minus 2xyz. So this term and this term will get cancelled out. Here, z into minus 1 minus z, and this plus z. This 2 will get cancelled out. Similarly, this minus 2x square and this plus 2x square. Again, it will be 0. So the denominator that we are getting, it will be 0. We are left with numerator, which is z dx plus dy plus x dz. Now we will directly see if this is 0, this has to be 0. So equating it to 0, observe this term z dx plus x dz. It is in the form d of xz. That is what we have written here, plus this dy as it is here. If we integrate this, we will get xz plus y equal to some c1. C1 is a constant, arbitrary constant. Okay. Now let us take some other multipliers. What? It should be, let us take x, y, and 1 by 2. Again, the denominator part I am leaving it to you now. As I showed you here, how we are getting 0. This time you will have to solve it and get a 0 there. I am just writing the numerator part because once denominator is 0, numerator will equate it to 0. Once we will integrate it, it will be like x square by 2 plus y square by 2 plus z by 2 equal to some, let us say, c2 dash. Now this 2, once I multiply to right side, it will be x square plus y square plus z equal to 2c2 dash. And now this 2c2 dash I have written as c2. Okay, which is an arbitrary constant. Now we have equation 1 and equation 2. Now what we are told is that this particular curve passes to x equal to 1 and y equal to 0. Okay, this one. If we put x equal to 1 here and y equal to 0 here, see, this term gets cancelled out. We are left with z equals to c1. Okay, that is what we are getting here. Once we put x equal to 1 here, y equal to 0 here, we are left with 1 plus z equals to c2. This is what we have here. Now observe, if I put value of c1 which is equal to z here, what will I get? C2 equals to here C1 plus 1. So I have got a relation between C2 and C1 using initial conditions, correct? But I know that I have a value of C2 as this, and this is the value of C1. I'll just substitute it here. This is C2, this is C1, and plus 1 as it is. So basically, I have eliminated C2 and C1, and this is my particular integral, okay, or particular solution. And this was our general solution. What was it? C2 and C1. Just we will write it in the form of phi of C1 comma C2 equals to 0. Okay, this would have been our general solution, and this is our particular solution. Okay, thank you.